Hi everybody. So today is a very, I hope, quick stream that was not really planned actually. So today I was able to test, so I sandwiched the boards together and I powered them on. So there are two ways to power it on. So one is using the onboard USB plug from the Disco board, and the other one is via the header. But you have to change a jumper from the Nucleo board in order to tell it where the 5 volt is coming from. If it's from the USB. Onboard USB from the ST-Link, the onboard USB user USB, or if it's an external one provided via the V-in pin, which can be higher than 5 volt. So here it's in the default configuration, that is the 5 volt is coming from the ST-Link. So I just plugged the cable and I was able to, so if you remember, I did remove U204 yesterday because it's not wired correctly, and so I was able to test the power button, and just by keeping it pressed for about half a second we powered the board on and off. So that's great. That means that the supply rails are stable enough. Nothing is burning, but we already tested that yesterday. So what I would like to do now is maybe the next major step is test the FPGA bitstream upload. So if you remember correctly, on the Nucleo board, I can take, I'm gonna grab one and I'm gonna show you. So I think it's this one, or no, it's not. It's that chip. So you have one chip here. Sorry, like this one. And this one is NOR flash. So that means it's a chip used to store non-volatile data. It's kind of like a flash USB drive, except that it's a NOR flash, so it's optimized for reading speed and not for writing speed. So we have some code already which does read the FPGA, so it's called the bitstream. So the bitstream is basically a binary file that you must send to the FPGA in order to tell it what to do. So the bitstream is loaded from the SD card to the NOR flash on board, and once it's in the NOR flash, the Nucleo board will send it to the FPGA at startup. So let me take this, which is my micro SD card. Okay, and let's reset the board. So for now, if you go in the settings menu, which is the cog on the top right corner, you have a few buttons, including erase user settings, load FPGA, erase FPGA, and button A. Button A is used to send the bitstream to the FPGA, and load FPGA is used to load the bitstream from the SD cards to the FPGA. So let's use the terminal. It's not the same COM port. Would it be like just 6? No. Which one is it? 7, why not? So if I reset the board, okay, terminal is showing data, it's alright. So you see that we have the first EEPROM, which is initialized, which is the one for the user settings, and another EEPROM is initialized, and that one stores the data about the the bit streams that the board knows about. So if I go on the cog and click on load FPGA, on the screen we are gonna see some lines appear. Well, we should. Okay, yeah. No previous image found. Written. Okay, so the bit stream is stored in the NOR flash. So if I press button A, I should send the bit stream to the FPGA, except that I don't want to do that right now, so I'm gonna erase because the bit stream that's loaded is the one that comes from the code that Wojciech wrote. But the thing is that he wrote that code for the FPGA evaluation board, which is not the same device as the one that we have on the proof of concept. So let's have fun today, starting the very nice Lattice Radiant. And what I would like to do is just start a project and make, so we have a test point here. I would like just to make this test point have 1 Hz signal at the output. Sorry, I misclicked and tried to send some code to the FPGA, which shouldn't be good. Okay. So, all right. Let's try to create a new project. A name we are gonna call it Blinky. Okay, seems nice enough. So it's an LIFCL40 in a package which is QFN72. We use the 9 speed grade 9, sorry. Okay. I guess this is good enough. Okay, so I never used Lattice, so I don't really know how it's gonna go. So I don't even know. Okay, I don't even know where to start. File list. I don't have any file actually in the implementation. I thought that I would have some. Okay, let's see what Wojciech did. So it's here and here. What does our folder look like? Hi Hervé. So today we are gonna try to upload the bitstream to the FPGA. I don't even know where my project is stored. Where is it? Oh, okay, why not? Blinky, here it is. Okay, so I guess we have to go in the impl1 folder and then aha. Okay, I'm already lost. Hi Sylvain, how are you? So yeah, this is kind of an unplanned stream. I will try not to be too long today because I would like to sleep a bit. But so I just put the two boards together and powered them on together for the first time, and I measured the voltage rails, and by setting the kill pin to 1, so that it's an active low pin, so that means enabling the power, the voltage rails stay active and have a very good value, like within 1% from the target value. So power supply seems to be working great. More work could be done on the power supply to stabilize it because there are some filters that need to be designed and so on, but we will have a look at that later on. Right now I'm trying to create a very simple VHDL project to kind of make a Blinky and try to upload that to the FPGA. But I don't even know where to start actually. It's not an easy software to use. Okay. Main.vhd, where is it? Oh, there it is. Okay, great. So, okay, I will do the same. So, folder called source, and then imp1 because it's the default name for the implementation, and main.vhd. Well, can I open the software twice? Oh yes, that's nice. So let's open Blinky on one side and Wojciech's project on the other side. Okay. Okay, so we have the main file right here. We will copy those because they are very, it's like the include stdio and include those things from the C header files. It's kind of the same thing. Okay, I have no idea whether I do need an external clock or not. Oh, lots of signals. So let's see IP catalog. What do we have here? Maybe I will have to provide a clock to it. Yeah, PLL is always good, but if you don't have any source clock, you won't be able to have anything going on in the PLL. Oh yeah, we have a PLL. Oh, oscillator. What is it about? Okay, so The way Lattice works is that you have kind of you have a catalog of IPs, so intellectual properties that you can use and reuse, and you have this kind of PDF document that you can have a look at if you want to know how it works. Let's try using one, and we will call it ask. Ah, you can't name it ask. My oscillator. Okay, great. Oh, I see that I can pick from a range of speeds. Let's use 50 megahertz. Low frequency clock. Okay, said I guess it's the serializer, deserializer, which I don't need, and this wonderful CFG LMMI CLK. What is it? Oh, it's an LMMI clock, which I don't really know what it is actually. Maybe this is all very naive, but let's use that. So file list, you have oscillator, okay. And so ports, we are gonna have only one port, which is gonna be Blinky outputs. It's gonna be an output, and it's a logic signal. Okay, that should be the end of our entity, I guess. And so if we look at what Wojciech made, it's basically, yeah, you have only the the IOs, physical IOs that are here, so we only have that one. Signals, we have, of course, the clock. So clock 50. If we can make a working project, I will be happy. Then if we can upload it, I will be even more happy. Sorry, getting lost in the notifications on the side. So we have this signal, which is the clock 50, and I don't think we need to add again all the signals that are the outputs. So now we would have components. So let's have a look. PLLOSC. Yeah, okay. So that would be component. My OSC is port. Okay, what do we have? HF out and I. Oh, okay. Maybe we can then simplify this and only have the low frequency output, which is at 32 kilohertz. I guess. Yeah, okay. Oh, okay. Let's make it like that. Port, then we will have, for the name of it, LF clock out O. Okay. Oh yeah, no music indeed. Hi Wojciech, sorry, didn't see you. Yeah, you're not late, don't worry, it's just that I forgot, I just didn't plan this stream and I felt like doing something like that today. You're right, YouTube, and I still didn't pin the link to the playlist that I use, so let's scroll. No, not yet. Yeah, okay, that one. Oh, can I maybe like this? Oh yeah, okay. Except that YouTube doesn't allow me to scroll past the 27th video, which is not very useful. So let's do like this. And okay. Okay, all right. And no ducks tonight. I'm going all alone. I ate the ducks. Sorry. Was nice though. So component is implemented. So I guess now we will need to define our entity. So Wojciech, if you feel like telling me things to do or not do, do it, feel free. Because I'm going like without any experience in this, so well, no experience in this software. I did some VHDL some time ago, but it's beginning to be a bit old. Okay, so I need to port map. Yes, okay, so let's my oscillator port map, and we are gonna have, oh, so it's LF. Oh, we don't have any auto-completion, of course. LF clock out, which will become clock 32K. Where does that start? I think I missed something. Because there is an end magic at the end of the. Oh yeah, okay. Yeah, of course. So. Okay. It's already telling me that I have a syntax error, which, given that I don't have a lot of things. Oh yeah, okay, it's because I have it. Okay, it doesn't. Oh, that's the kind of language that doesn't like the trailing commas and so on, which is kind of annoying. Okay. So now I think I should add an internal signal, which is gonna be counter. I think I can do that. Can I? Oh, there is this thing of the sensitivity list and so on. I don't know how it goes. Oh, that's starting to be far from now. Whew. Okay, I realize now that I haven't done VHDL for maybe a bit too long. So let's try to see if I can find an old project that I did and how I did it. Those were quite simple, so if I can find one, that should be easy to analyze. I don't know where I would have put that though. one. Well, maybe I don't have anything that I can refer to. Oh, I do have an old one. Oh, yeah, okay. Oh, I think I remember that now. Okay, so I see that the brown and dark gray is the best choice of color possible. Hi Manuel. Yes, time for some ChatGPT. I hesitated to do that, but nah, I'm gonna try to train my brain. I'm here for fun, not for some utmost efficiency for my work, so I would like to remember that and experiment. So I have to wait for an event, and maybe I can yes, okay, let me just have a look. Maybe yeah, okay, so I guess there is a problem with this way, which is that I don't know what is the size of an integer. Okay, let's use another approach. Oh yeah, the 8086 is definitely a very interesting chip. So Wojciech did a lot of work trying to implement the IQ interface for that. It's very interesting to be able to drive the IQ from basically whatever we want. And we really hope that with that we will be able to do like really the do-it-all radio and be able to implement nearly all the protocols that we can think of. So I guess So that would make me a counter, a 16-bit counter. So now I have a process in which I will wait until the clock, there is an event, so I guess an edge, and the clock is high, so basically rising edge. Every time I have a rising edge, I will do, I don't know if I can just simply do that. Character 0 is not in type, blah blah blah. Oh yeah, I guess so let me just copy from okay, oh here Wojciech do use the integer type, but I don't know how much, so maybe I can okay. Syntax error, so that does not match with the integer literal. Well, it seems that an integer should be at least 32 bits, and we are not trying to have any kind of optimization here, so okay, that's this one. Counter increments to 1. I'm not sure if I can just swap an output, so let me okay, we increment counter by 1, and I guess we can simply do I don't even remember how we do an equality check in VHDL. Like, can we just do an equal or something like that? Maybe I can do oh yeah, I'm gonna do that. So so 15 bits for 32,768. I don't want to think 16. Yeah. So I think this should be enough to get us a blinking LED. Oh my god, this is the slowest blinky I ever did. And I'm not even sure it's gonna work. Ah, sorry, I closed the wrong file. Okay, what are you telling me? My OSC is not a type. How dare you? VHL Blinky, the most painful of them all. How is it that it's not a type? Oh, I guess. Huh? I don't know, let's try running synthesis and see what it throws at us. It's complaining, of course. Okay. Yeah, basically, you didn't do your stuff, don't want to compile. Okay, fair enough. Hello world in VHDL. I guess you would need some kind of UART or something like that, or maybe blink the LED at a specific rate. I guess I'm still missing a few ends somewhere. Yeah, okay, and process. Aha. Okay, so now I have to understand why it doesn't want to find my OSC type, which I don't even know where, which one is it complaining about. Okay, this one. Aha, so that's an improvement. Now it complains about things not being declared, though I'm pretty sure that it's right here. Oh. Name. Okay, so thing is, it's giving me errors that I don't even understand. Ugh. Counter is not declared. Oh, maybe. I don't remember everything. But I do remember that there is kind of a sensitivity list in the processes. Okay. Is component spelled right? Ah! That was a good catch. Okay, so only one mistake. That's an improvement. So index name prefix type integer is not an array type. Yeah, okay, no worries, Wojciech. I'm just gonna find it. It's simple enough. So I guess it's complaining about me trying to increment counter. So let's check VHDL, increment integer. Ah. So it seems that, yeah, you should be careful when you use integers. Can I do maybe something like that, and so I should do this. Counter is not declared. Ah, not again. Bye Sylvain, see you next time. Okay, so maybe I'll try to do the Google search in front of you so that you are able to see it, how lost I am. So I'm looking for the way variables are used in processes. Maybe I should that doesn't seem to help. Okay, oh, yes, of course. Okay, now it's working. At least it's not complaining too much. Synthesize. For now, no errors. Nice. Okay. Well, maybe we will have a working VHDL project at some point, and if we are able to upload it to the MCU, I will go to sleep happy. So where is the PA13B port? I don't even know where it is. Ah, okay. So, PR13B, PR13B. That one. Assign. Is it assigned? Okay. Why wasn't I able to assign it? So let's just check. PR13B is 43. Okay. Oh! Okay, I guess that's why. go on, create the file if you want. Place and route. No more mistakes. Great. Yeah, fingers crossed. So we now have the bitstream file. So let me insert the micro SD card in the card reader. And go get it. So it's nope, not here. Okay, that's one. I guess if I have a look with Notepad, yes, that's... So this start is the... It's how a bitstream is supposed to start. I think that's the name I decided it would have. Okay, so eject, insert. So you are not able to see that. Really, it's a shame, but I don't see how I could do. So I'm just gonna load the image, and if I have a look, yeah, of course it's not showing. So nope, sorry, not that. Well, anyway, let's close that one then. Load. So 808220. Yes, that's the correct number of bytes. So now I will use the debug mode because I expect that it's not gonna work from the first click. So I want to see it. Well, maybe we can first go and disable all the breakpoints. Run. I think I clicked too soon, and yeah, it's gonna fail. Anyway, let's rerun. Okay, run. GUI started. Let's power the board. So it should be good now. And let's see here. Did it work? Like first time? Let me start the oscilloscope. Okay, I really did not expect that to happen, I have to say. Yay, clap, clap, clap soundboards. Okay, let me just join the live channel so that you can clap for me. Hi. I want the clap, please.
Oh, wait.
Woo! Thanks. Well, given that the main battle with Lattice is done, I think I'm gonna stay here with you. If anybody else wants to join us on the M17 Live voice channel, feel free on the M17 Discord. So, in the meantime, so I see that I have an ID code here. So what could we have for problems? We could have an error during the transfer of the file, which would then make the transfer be invalid. And so for that I would have to slow down the SPI bus, which would be feasible because, as you saw, it was like super fast, like less than a second. So, and given that we are supposed to only flash the FPGA once at the beginning, if it takes some time, that's not a major problem. So that we could have a problem during the upload because the bus is not reliable. We could have an error in the way the transfer is done, like maybe something is not sent correctly, maybe I forgot to do something, which would then make the transfer invalid. So we have the status register. I'm supposed to test the status register to see if it's not containing any errors. I don't do that yet because I didn't want to do that. I just wanted to have a look at what the status register would be. Also, maybe I can quickly have a look at the done and init and pins. Where are those? Wait, what's that? Okay. That's weird. I don't believe that the init and done pins are what is expected. Oh! Oh shit! I reset the boards, that's why it's not showing what I expected. Oh, and now the status register is not the same. Interesting. Let me check again the signals. Okay, done is low. Programming is low. And it resets again. Okay, it seems that it likes resetting user settings. Yeah. how could I do that? Because every time I'm okay, if I just don't place it flat on the table, maybe. Done. Okay. Okay, I uploaded it twice anyway. I'm gonna need to. Okay, let me just solder very quickly a wire on the ground pad. Otherwise, I'm not gonna be able to probe the outputs. Yeah, one possibility, of course, is that the VHDL won't output any clock signal. Okay, I'm not gonna show you everything I'm doing right now. It's simply stripping wire and soldering it to the board. Not very interesting. Oh yes, soldering station is not powered on because where is the power cable? There. Okay. Okay, it's hot. Okay. All right. Let me restart the terminal. Like this. Okay, FPGA code is uploaded. So yeah. I'm gonna show the scope. So that you can see at the same time. Okay, I'm gonna remove this. Okay, so 1 second per division. We don't need any zoom. Where is that? tactile pen. Cursors, don't need them either. Okay. And probing. Oh, that's weird. Okay, so nothing at the output, except like 400 millivolts. And I have no idea why. So this should be 3.3. Oh yeah, maybe scale is a bit too high, position and offset. Let's reset that. So this is 3.3 volt rail. Wait. It would seem to indicate that I don't have 3.3 volts at the output. Aha. Okay, so maybe I powered it down. Okay, so this is 1.8. 3.3 seems to be okay. One volt is good. Let's restart. So it seems that it's always high. So I'm gonna power down the FPGA. No, I should be... No, okay. Power on the FPGA. So it seems that the default state of the pin is high. So for now we don't have any indication that the upload is working. So let's maybe have a look at the status register. That would hold very interesting information, I guess. Okay, let me have a look if I still have the datasheet somewhere. That one. Oh no, I guess that would be the sysconfig document, and then so this is the guide explaining how to upload everything to the. Okay, sorry, getting confusing. So configuration modes, no, I guess it's device status register. Okay. So sometimes it's 3 and sometimes it's okay 3 3 4. Okay, 3 7 or 4 8. So it's a 64 bits register. Let me just have a look at the code where I dump this register, which is in task FPGA. This is where I drop the content to the shell. So yeah, okay, the first 4 bytes and then the 4 last bytes. I don't know in which way it is read or sent. Okay. Sorry. So we have the 4th bit, so I guess it would be 4 from here. Okay, so that would seem to indicate, oh, reset value, it's supposed to be all zeros. Interesting. Okay, let's try first lowering the SPI speed. 2 point something megabit per second is more than what we need. And let's run the code. So I'm not gonna investigate too far today. If I'm able to make it work, great. If I'm not able to make it work with that, I'm gonna leave it here for today and have a look at that tomorrow alone. Okay. Okay, board is powered on. So load FPGA. What did it show? Oh yeah, no, it's button A that I need to do. Ah, interesting. Why is it hanging? Okay, very interesting. It seems that wait. Wait a second. Oh, there we go. This shouldn't be here. Okay, so let's program the FPGA. Okay. Okay, so it seems that the FPGA stays busy. Interesting. Okay, next step I think is gonna be doing all that from the command line, because having to click and move and so on is very annoying. If I could do that from the computer, it would be much easier. Okay, so flash. Ah yes, no, of course not. It's not gonna work like that. Yeah, no. Okay, not good. So the ID code is the identification code from the FPGA chip. And if it reads 0, that means that the FPGA is not awake, so I think I powered it down. So, okay, let's do this. No, it's still 0. Why? Okay. Ah, okay. What is buffer RX? Okay, it seems that there is a problem waiting for this flag. Okay, let's try something else. Okay. ID code is wrong. Oh yeah, of course, when I reset the board, the power is shut down for the RF board. That's why. So I should do that first, and then power it on. Okay, let me just disable the breakpoints. So now if I click on the button A, yeah, okay, the FPGA seems to be always busy, which is very strange. Okay, well, sorry guys, we are not gonna see the FPGA do anything today, I think. So yeah, at least we tried. We have very quick VHDL codes. We know that there is a problem with the fact that so just to explain quickly what is happening when I'm trying to flash the FPGA. So first I do some housekeeping, and then I kind of reset the FPGA. So I write program and pin to low. Sorry, that's the DMM. Then I acquire the mutex on the SPI bus, because this SPI bus is used for several things and I have to be sure that I'm the only one using it. Few callbacks, housekeeping. Then first I transmit 5 bytes, sorry. So first is 0, because it has to be a 0, and then this is the SPI port activation key, which tells the FPGA that I'm going to start discussing with it through the slave SPI port. Okay, getting tired. This seems to happen all fine, because when I read the ID code I do have some data and it's always the same data. I don't know what I should read, but I read every time I read it, I read the same thing. So it seems that I'm activating the port correctly and reading the ID code. That's nice. Then I'm sending it ISC enable, so basically telling it that I'm gonna start messing with the configuration file and the bitstream. Then I erase the previous one, and erasing it can take some time. I don't know how long, just can take some time, so I wait for it to be done. So for that I have to check the busy flag, and as long as the busy flag is 0, it means that it's busy. So maybe maybe that's the opposite actually. I don't know. Yes, maybe that's the opposite actually. That doesn't make sense otherwise. Let me have a quick look. So that would be here. Read 1-bit busy flag. So if you have a look at the ISC command, ISC erase, note number 2, it says use LSC check busy to check the status. Okay, so yeah, so I don't know what I thought when I did that, but that's the way it should be. So let's retry. So I tell it to erase everything, and then I wait for it not to be busy anymore. And when it's telling me that it's not busy, I start sending the bitstream. So I first send the command bitstream burst, and then follows my bitstream, my actual file, which as you saw in the on PuTTY, it's quite a long file. Okay. Okay. Let me check very quickly. It doesn't look like anything is happening on the test point. So yeah, I don't really know what that would mean. I'm gonna have to debug that later on. So yeah, so basically I send the bitstream, then once I'm done sending the bitstream, I check the status register, I disable IC, and then I'm done. So one of the possibilities is that I'm moving the NSS signal too much, and so maybe I'm not supposed to move that as much. You fixed a major gripe with UI. What do you mean, Jay? I can try one last thing. If I slide my finger along the screen through the PTT, it will activate. Oh, really? Oh, yeah. Okay. Oh, any button, that's... Okay. Okay, so it's easier to tap the settings button, I guess. Nice, very nice. The last thing I test, and then I'm gonna go to bed. Okay. Okay, FPGA plugged down. No, still nothing. So the init N pin is high, the done pin is low, which I don't really know what it means. Okay, so init N would seem to be able to indicate an error condition. The music stopped. Okay. Oh no, configuration error is init N goes low. And in my case, it's high, so it would be good, I guess. Okay, so as long as the done pin is low, it seems that it means that the FPGA is in configuration mode, which it stays in. So there is a problem with the configuration upload. The FPGA stays in configuration mode. I don't know why. We will have to investigate that. Anyway, that's gonna be for later. So that's it for tonight. I hope you enjoyed. It was nice. I see that some things do work, which is definitely something good and motivating. So I will be continuing my investigations, and I will let you know and maybe do a new stream whenever I have something working. So good night everybody, thank you for following along tonight. 73s to all of you, take care, and see you on the next stream, I guess.